Alright, it's time to do some work on simplifying radicals, and that's your learning target is I can simplify radical expressions. Alright, let's get going. Okay, so we're going to go through a couple of definitions real quick. And the first thing we're going to define is what a radical is. And a radical simply is just a square root. And actually it doesn't need to be just a square root. It could be a cubed root, or it could be a root to the fourth, or fourth root. So you're looking at something like this, or sometimes it looks the exact same but it's got a little 3 here. It can be one of those type of things. Okay, and the radicands, what a radicand is the expression inside the root. Okay, so whatever little numbers we have going on inside here, that's called the radicand. Okay, and then there's this last thing we're going to talk about or define here is the perfect square numbers. Okay, and those are numbers that have whole number square roots. Okay, so if we give some examples of these whole number square roots, the square root of 4 is 2, right? Okay, so an example of a perfect square number would be the square root of 4. It's perfect, right? Another example of this would be the square root of 9, because the square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. And you see this pattern just continues to go on. The square root of 36 equals 6. It's just whatever this number is squared inside what is inside the radical, okay, or the radicand, right? So another one, let's go to 10 here. We'll try to get to 10. The square root of 49 is equal to 7. The square root of 64 is equal to 8. The square root of 81 is equal to 9, and finally the square root of 100 is equal to 10. This is a little cheat sheet that you might find helpful to you when you're doing some of these problems here, is use this to know which numbers you're trying to get to, what perfect square numbers really are. Okay, let's go through a couple of rules right now, the rules for radicals, and the first one we're going to talk about is the product rule for radicals. The product rule for radicals says that if you have the square root of a number and you multiply that by the square root of another number, really it's the same thing as saying the square root of a times b all under one square root. Okay, it's the same exact thing. The quotient rule is like it. If you have the square root of some number and you're dividing it by the square root of another number, that's the same thing as just the square root of whatever a is divided by b. It's the same exact thing. Okay, let's go to your key concept. So to simplify radicals, the first thing we want to do is find the perfect square. What number can be multiplied by another number to equal what's the radicand? Okay, find the perfect square. So we got to factor the radicand and split the numbers into two different radicals. Try to get one of the numbers that is being factored to be the perfect number. And second, the second thing you want to do is then simplify that. Simplify that. So take the square root of the perfect number and keep the non-perfect number in jail. Okay, and I'm going to explain that, what I mean by that, with this first example. So for example 1, we are asked to write the expression in simplest radical form. Okay, and you're given that we have the square root of 45. So what we like to think about this as is that this square root sign is jail. And that number 45 is in jail, right? Okay, and we know that when you're in jail, the only way to get out of jail is if you're perfect, right? If you're a perfect inmate, then you may have a chance to get out of jail, right? But if you're not being perfect, then they're going to keep you in jail. So it's the same type of thing here. We've got the square root of 45, and that square root is marking the jail. Okay, we need to try to find perfect numbers that can get out of jail. Only the perfect ones can get out. Okay, so first let's split this number into two different radicals. Okay, Okay, and we know that some of the factors of 45, one of them is 9 times 5, and 9 is one of those perfect numbers. Okay, so we've got the square root of 9 then times the square root of 5. Okay, and these are both in jail now, right? The square root of 9 is in jail and 5 is in jail. But 9 just happens to be one of those perfect numbers that we like so much. So we can find the square root of 9, and we know square root of 9 is just 3. And we can still multiply that then by the non-perfect number, that naughty number 5. Okay, and this is the simplified radical version of the square root of 45. Okay, example 2 is the same type of thing. We've got the square root of a fraction, the square root of 3 over 16. We can rewrite this as the square root of 3 divided by the square root of 16. We can split it up into those two different radicals, one in the numerator and one in the denominator. Now we know 3 is not a perfect number. It's a naughty number. But 16 is one of those perfect numbers. It's a special one. It's been doing what it should do. So we can get 16 out of jail. Square root of 3 has to stay the same. However, the square root of 16, that just reduces down to 4. So our answer then is the square root of 3 divided by 4. And that's our simplest radical form. We got the 16 out of jail and it became 4. Became a whole new person, a whole new number. So example 3, I just want to make one little piece of information you guys need to remember or you need to know, is that simplified radicals, which is what we're trying to do in this lesson, do not have radicals in the denominator. They never have radicals in the denominator. So if you see some expression with a radical in the denominator, you're going to know right away that that doesn't work. So for example, right here, this 6 divided by the square root of 2, that is not a simplified radical because there's a radical in the denominator. So in order to solve this here, we've got 6 divided by the square root of 2. And if we want to get rid of that radical in the denominator, what we can do is we can multiply it by itself. But if you multiply something, you have to keep it all consistent, right? When you're multiplying fractions, all this is really equal to is 1. So we're not changing anything about the actual expression. We're just multiplying it by 1. That'll keep it the same. However, when we do that, we'll see the numerators multiply to be 6 times the square root of 2. And the denominators multiply to actually equal 2. The square root of any numbers multiplied by each other is just whatever is inside that number. Okay, so the square root of 2 times the square root of 2 is just 2. It cancels out that square root. Okay? And then this last step that we can do here in order to get the radical completely simplified is we can cancel this 6 and this 2 because both of them go into each other. 2 goes into itself once and 2 goes into 6 3 times, which means that our final answer is 3 times the square root of 2. So a simplified version of 6 over the square root of 2 is 3 times the square root of 2. All right, that's it. Hope you enjoyed.